Okay, how do you add, subtract, multiply, and divide those radicals anyway? So this sheet is just to see some patterns and before we learn the actual operations. So I have gone ahead and found the decimal form of each of these. Press pause and do that yourself. So practice entering these into your calculator, finding the decimal form, rounding to the nearest tenth. Really will rarely ever ask you for the decimal form. But this is for comparison purposes. We're trying to see some patterns. So pause, do that, come back, and then take a look at question 2. It says half of the above expressions are not in simplified form. They are rewritten in the first column of the table below. Each of these expressions is equivalent to another expression above. Look at the decimal approximation and match them. So, for example, 3 root 5 plus 4 root 5, that's the first one, is 15.7. What else is 15.7? So this one and this one, 7 root 5. So 7 root 5. Okay, then 8 root 3 minus 2 root 3. So that's this one. That's the same as 6 root 3. Then root 2 times root 7 is, where is that? Here, 3.7. That's the same as root 14. I'm actually just going to minimize this a little bit. Let's see. There we go. And then, so we can see all of it. 3 root 2 times 4 root 3, 29.4 is the same as this one, 12 root 6. Root 30 over root 6 is 2.2, and this is 2.2. 12 root 21 over 6 root 7, 3.5 is equal to 2 root 3. Root 6 over root 5, 1.1 is equal to root 30 over 5. And then 5 over root 3 is 2.9. That's the same as 5 root 3 over 3. Okay, so these are not simplified, these are simplified. So we want to look at the patterns of how to get this simplified form. So examine the table above and predict the simplified form of each of the following. So basically here, this is adding, and you can see that the radicands are the same, and that's the same radicand in the end. 3 plus 4 is 7. So basically you keep the radicand the same. It's like terms. It's like 3x plus 4x is 7x. So this is 7 root 5. Same with subtracting. 8 minus 2 is 6, root 3. So here, adding both root 10, 2 plus 7 is 9, root 10. Both root 7, 8 minus 3 is 5, root 7. Now let's look at multiplying. So you multiply the radicands together to get root 14. Can't simplify it, there's no factors of 14 that are perfect squares. Here we multiply the coefficients, 3 times 4 is 12, and the radicands, 2 times 3 is 6. Okay, so coefficients together, radicands together. So 13 times 5 is 65, so that's root 65. 5 times 8 is 40. 3 times 11 is 33, so root 33. Then dividing here, so root 30 divided by root 6 ends up being root 5. So if these are both in the radicand, then just like you multiplied radicands together, you divide radicands together. So 30 divided by 6 is 5 underneath the radical sign. This one has coefficients, so you do those separately. 12 divided by 6 is 2, and then 21 divided by 7 is 3 underneath the radical. Okay, we'll talk about the next ones in a sec. 60 divided by 5 is 12. So that's root 12. Now, that can be simplified in this case to 2 root 3. The next one, 24 divided by negative 3 is negative 8. 12 divided by 6 is 2 underneath the radical. Then these ones where you have radicals in the numerator and denominator, but they don't divide into it. So 5 does not go into 6. 3 can't, there's nothing to divide in the numerator. So notice how in these simplified, what we're calling simplified, there are no radicals in the denominator anymore. So this root 5 is now 5. Well, when you're finding equivalent fractions, you're multiplying top and bottom by the same number. So what do you multiply root 5 by to get just 5? You have to multiply by root 5. Well, if you do it in the denominator, you have to do it in the numerator. Root 6 times root 5 is root 30. Here, I would have to multiply by root 3, top and bottom, so that would be 5 root 3 over 3. Okay, so that's what we call rationalizing the denominator. So here I'm going to multiply by root 3, top and bottom. So that's going to give me root 21 over 3. And here by root 7, top and bottom. So that'll be 6 root 7 over 7. That's called rationalizing the denominator because these are now rational as opposed to irrational denominators. Okay, and that's it for this note sheet.